So here we're going to look at the Bayesian decision theory. So we, similar as non-Bayesian, we're actually going to learn two different methods. So the first one is called the expected payoff. Another one is called expected opportunity loss criterion. So we have two different payoff, and two different methods we're going to learn in this part. So the two methods are following. First is called expected payoff. Another one is called expected opportunity loss. And so for the expected payoff, and after you calculate expected payoff, what you're going to show, your chosen criteria will be you're going to select the alternative where the expected value for the payoff is the best. And for the second method called expected opportunity loss criterion, and then you're going to select the decision alternative with the minimum expected regret value. So first, let's look at the expected payoff method. And so you actually will notice that it's not that complicated. Maybe you already use it in your daily life. So first, what do we mean by expected value? So the expected value is to identify the best or recommend decision alternative when you're considering the probability. So the decision alternative yield the best expected value is chosen. First, let's look at how we calculate the expected value for each decision alternative. So if you have three options, you should have three expected value. So the expected value is being calculated using the following formulas. So basically what you're going to do is you are using the probability. So the P is the probability for the state of nature, and the V is the payoff. So let's see the decision alternative 1, and then you're going to look at the possible payoff. So the possible payoff under different state of nature, and so for each decision, each payoff under that corresponding state of nature, you're going to multiply by the chance. The probability of the state of nature, So it's kind of complicated to look at this formula. Let's look at example, then you will have a very, very clear idea how to do the calculation. So we'll look at the same case, the snowmaking machine. So we can see we have two decision alternatives. Therefore, we have two expected values. We have two expected value. One is expected value for not listen. Another is expected for listen. So we have two expected value. So in order to calculate expected value, we first of all identify the payoffs under the state of nature, under the decision alternative. So for not listening, we have 20,000, 30,000, and 50,000. So to calculate expected value for this one, we make sure we understand all three outcome is attached on the state of nature. So at 30% chance have mild winter, 50% chance have typical winter, you have 20% chance have severe winter. In order to calculate this expected value, what you need to do is using the payoff under that state of nature, multiply by the probability of the state of nature, and then plus them together. That will be the expected value. So let's look at the answer. So this is the expected value for not listening snowmaking machine. 30% times 20,000, 50% times 30,000, 20% times 50,000, and add them together, you got $31,000. So that is expected value for not leasing snowmaking machine. So now how about leasing snowmaking machine? And the $37, 30% chance have $30,000. 15% chance have $35,000, 20% chance $40,000, and then you add all the product together, you got 34,500. So this is the the expected value. So now what is your decision? So obviously the decision criterion is that you're gonna choose the one give the highest value. So therefore, based on the expected value, your decision gonna be you're gonna choose not lease snowmaking machine. Your decision gonna be you will lease the snowmaking machine because that's gonna give you $34,500. If you're not leasing, you're only expecting $31,000. So this is called the expected value. So it's, as I said, it's pretty straightforward. Let's look at our attendance check question together. So then you will be able to know how to do the calculation for that case. So now let's look at the practice question. Last time we did max and min, max and max. So now we're going to look at question number 3. What is decision based on the expected value? To answer that question, we can do a little bit calculation. But first of all, you have to know the probability 0.4, 0.2, 0.4 by reading the first paragraph, right? So reading the first paragraph, you identify 0.4, 0.2, 0.4. So now let's look at what is the decision based on expected value. First, we have to do the calculation, right? So first, we have to calculate what is the expected value of the model A, expected value model B, and expected value of model C. So based on the example, we learned that we're gonna use the payoff 10,000, 50,000, 40,000 combined with the probability to calculate expected for A, 8,000, 18,000, 12,000 using those values combining with the probability to calculate B, and the same thing for C. So now let's do it together. So A, let me just fold it. So I'll try to combine everything together so you will be able to see the table along with my calculation. So let's look at how we get expected value for A, model A. So 10,000, right? So 10,000 is related to the probability 0.4. So you only have 40% chance to get 10,000, and then plus 15,000, you have 20% chance, and then plus 14,000, you have 40% chance. So if you use calculator to do the calculation, so you will get $12,600. So $12,600. And now look at the B, 8,000, 18,000, 12,000. So that will be 8,000 times 0.4, and then plus 18,000 times 2, and then plus in the 12,000 times 4. So if you're using the calculator, and you will get 11,600. So this is the expected payoff for the B. So model C, so that will be 600, right? 600 times 0.4, 1,600 times 0.2, and then plus 21,000 times 0.4. If you have calculator, you'll get 14,000. So this is my first step. Now we're going to make a decision. Do you choose model A, model B, or model C? Yes, of course, model C, right? The reason is because 14,000 is the highest expected value among 3 models. That's why you chose model C. So in next video, we're going to look at how to make decision using the minimum expected opportunity loss.